All right, so I had a question earlier today about bumpers on the Fisher-Price model. So I'm gonna do a quick tutorial on how to do the bumpers. And first I'm gonna do how to do like a very simple, just 3D model for the drivetrain, and then go into doing the bumpers for that. So first what I'm gonna do is, I'm just gonna do this off of the Max Swerve drive system. So I'm gonna Google Max Swerve so I can pull up the drawing. Because I wanted to get a decent idea of how high my drivetrain bars are going to be. So I'm going to go to drawing, and it's going to give me some key pieces of information over here. Really what I want to know is like this height. How high is the drive rail bar compared to the floor? So it looks like it's about 2 3/4 inches from the ground. The wheels hold the drive base up. We got 3-inch diameter wheels, so I'm going to kind of use that as my baseline for this. So what I'm going to do is I'm going to create a plane off of the top plane. I'm going to make that 2.75 inches up. Then I'm going to do a sketch on that plane, look normal to it. I know that the rules specify that a drivetrain can't be any larger than 120 inches. So I'm just going to give let's see, if I do like a 28-inch side square swerve base, what's that going to look like? So 28 is one side, multiply it by 4 to get my frame perimeter. So that's 112. That's plenty of margin to the 120 max of the rule. So I'm going to do that. So make equality constraint for these two. Then I'm going to make this 28 inches. And that's my drive base. I'm going to create another piece interior to that because I know that I'm going to use 1x2 for this. I'm going to make this dimension 1 inch because that's what is interfacing with the module. And then I'm going to make these equality constraint again. And what's great about this is by dimensioning it this way with the equality constraints and then giving that 1 inch dimension, if I want to mess around and I say like, okay, I want to actually make this 26 inches, everything will move accordingly because I've dimensioned the things that I care about in this design. I care about the one side of the square drive base, and I care about using a 2x1 with the 1 inch facing top. So no matter what I do, if I make this a whole 30 inches, I think that's the max it can be. So that's 30 times 4. Yeah, so 120. So 30 is the max it can be. So I don't want to go any larger than 30. I'm gonna stick with 28 for this. And then I'm going to extrude that. And it's a 2x1, so I'm gonna extrude it 2 up. And then I'm going to give it a, just like a, not a fully, I guess, not a fully defined wheel. Like I'm not going to do the motors and the plates and everything that go in this corner. I just want kind of a representation of the wheel. So what I'm going to do is I'm going to sketch on this plane here, the outside of the drive rail, and I'm going to make a circle that's 3 inches long, and I want it to be tangent to this face. So there. And then I also have a floor based on the origin. And let's go ahead and make the floor just go all the way to that line there. And I'm going to do tangent to the floor here. And what that should do is lock the wheel in place because it knows the diameter of the wheel. It knows that this side has to be aligned with this side with the tangent constraint. And it knows that this bottom edge needs to be lined up with this line for the ground. And then I'm going to go ahead and extrude that into the frame. 1 inch is fine. So, I mean, it doesn't look beautiful, but it conveys what I need it to convey. And then what I'm going to do as well is I'm going to take, I'm going to actually make that extrusion a separate part. So new, boom. And then I'm going to do a circular pattern with the wheel. And I want 4 instances, axis of the pattern. Oh, okay, cool. So this is a good place to introduce the idea of a triad. A triad is a generic shape that we put at the bottom of our part studio to help everything line up. So on the top plane, I'm going to create another sketch. And I'm just going to create a square that goes along with these axes here. So X positive goes up, Y positive goes to the right based on this axis up here. So I'm going to go in regular rectangle mode, not center rectangle, and I want to hit the origin and then bring it out just like this. I'm going to make these two sides equal, and then I'm going to dimension this to 1 inch. Then I'm going to extrude it to 0.1 inch, and it'll become obvious hopefully in a second why. So now it's a really thin piece. It's actually extruding up, which I don't want. I'm going to change direction to have it extrude underneath the face, because I want the top of this piece to be pretty much exactly the same level as the top plane itself. Then I'm going to create another sketch on this face. And then I'm going to create an L shape like this, making sure pieces are staying vertical and horizontal. I'm going to make this small line segment equal to this small line segment, and I'm going to make these 0.1 as well. And then I'm going to extrude this L piece, and notice the L piece is the same as well as my axes, the positive X and positive Y axes, and I'm going to make it go up 0.9 inches. So what that does is it creates this box here, and this box is made such that each of these planes are perfectly lined up with the front, top, and right planes of the Part Studio, as well as this edge, and this edge are perfectly lined up with the X, Y, and Z axes. Z being the negative direction of Z, X and Y being the positive direction. So again, when I go back to do my, I'm going to rename this piece as Triad, just so I know which one it is. And then I could also do the same thing with here too. This is good practice to rename your parts as you make them, so you don't lose which part is which. Drive base, and this is drive wheel. So what I'm going to do now is go back to doing that circular pattern. I'm going to empty pattern is going to be the drive wheel. Axis is going to be the Z axis, and then I have 4 of them. So now I have my sort of drive base for my Fisher-Price model. Okay. Next, what we're really here for is the bumper sweep. So if you look at the rule book, if I go to 2023 FRC game manual, I can pull up the game manual and I'll look for the bumper section. So search bumper rules. I scroll down and I find this diagram here. So the bumper is comprised of 2 pool noodles that are 2.5 inches in diameter and a 3/4 inch thick piece of plywood. Now the height of the plywood is equal to the height of 2 of these pool noodles. So these are 2.5 inch diameter, so this total height is going to be 5 inches. So I'm going to use that information to create my bumper here. So what I'm going to do first is I'm going to start a sketch again on the right plane. And then I'm going to create a rectangle out in space. I'm going to force that rectangle to be incident to this part of the frame rail. So I'm going to make that just touch each other. And then I'm going to dimension this thickness as 3/4, just like it says in the rule book. And then I'm going to dimension this height as 5 inches because that's what the pool noodles require. Next, I'm going to create circles, 1, 2. They're going to be equal to each other. And then they are going to be 2.5 inches in diameter. And then what I'm going to do is use the tangent constraint. I'm going to make them tangent to the plywood, tangent to each other. So now they're perfectly touching only at one point. And then tangent to one of the sides of the plywood. So now that should lock everything almost in place except for the height of the bumpers themselves. So last thing is to do the bumper height, which I believe it specifies bumper height here. Bumper height. Oh, I know from previous reading that the max height for the bumpers is 7.5 inches. I'm just looking for where it says it in the rule book. Here we go. Bumpers must stay low. They must be in a volume contained between the floor and a vertical plane, horizontal plane at 7.5 inches. So that just means the bumper height can't go further than 7.5 inches. So I'm going to give myself a little bit of margin and then make my bumper height 7.25. So now it's fully dimensioned. You can see by the all the lines have turned black instead of blue. Then I'm going to create lines to touch each part of the circle. Boom. And then I'm going to make them forced tangent. There you go. And you see after I forced tangent, I didn't have to do both sides because it also, as I made the line, because I made it pretty vertical, it forced it to be vertical always. And so if I were to be tangent to one of these circles, and this is constrained to be perfectly vertical, then with those two constraints, it also means that it is tangent to this circle as well. So I could have done either way. If I made this a non-perfectly vertical line, I would have to do tangent to the lower circle and tangent to the upper circle. So it could have been done either way. Okay, so next I'm gonna have to do a sweep extrude, which is gonna be, if I get out of here, so my sketch is there. I'm going to do a sweep. And then the faces that I'm going to sweep are the faces of that sketch. And my sweep path is going to be along the outer frame of my drive base. Okay, once I select all four sides of my drive base, I click OK, and now I have my bumpers that are made to spec. Not a whole lot of time invested in it, but it gets me the appropriate order of magnitude, size, and dimensions to get my Fisher-Price robot up and going. All right, let me know if you have any questions. Thanks.